So when considering long division of a polynomial, it's helpful to know why we use it. So later in your specialist studies, you guys will be looking at calculus. Now, when we're looking at integrating and differentiating different expressions, sometimes we can't integrate or differentiate when they're in this form. Sometimes we need to get them so that they look like this, so that they fit into the certain rules that we have. It's a really good way of adjusting the way that something appears to make it fit in with a process versus having to go around the really long way, which would require a lot more math than what you guys get in high school. So that's why we have long division of a polynomial. Now, there are two main things that you need to do to start off with. You need to check that the polynomial has all the terms in order and they're accounted for. So let's say that we had this expression here and it was being divided by another polynomial. Now, that other polynomial could be anything like x plus 1 or, something simple like that. But what we're looking for is that the terms are ordered, meaning that your x's and the powers above them are all in order. So here you can see I've got x cubed, x squared, and x. So this one does have them all in order, and they have all been accounted for. So this one would be ready for us to start doing long division of a polynomial with. Now, it doesn't matter about the coefficient in front, just what's happening with our x terms. So x cubed, x squared, x, and then our constant. So that one as well isn't missing any, and they're all in order. Now, this one here, we've got x cubed, x squared, and then we should have an x term. So if I was going to do long division of a polynomial with this expression here, what I would need to write is 3x cubed minus x squared plus 0x plus 5. So I still need to show that term in order to make everything line up and make it make sense. So this is the one that we would use, not this one. Now, this one below here, it's pretty easy to see what's wrong with this guy. He is not in order. So in order to put this in the correct way that it should go, it should be minus 5x4 as the leading term of this polynomial. Then I'm going down, looking for my x cubed, plus x cubed. Then I'm looking for the x squared, plus 7x squared. Then I'm looking for my x term, minus root 5x. Then I'm putting my constant on. So you can see there everything took the power of the sign in front of it. So if it was a negative, it stayed as a negative. We didn't change those, but now it is in order and it is, all of the terms are accounted for. So I could use that one or that one now. Okay, so let's start looking at the process. Let's say I'm given a question like this where it's asking me to use long division of a polynomial. Not 3. Where it's asking me to use long division of a polynomial to determine the quotient and the remainder of this expression. So that's the first polynomial, and it's divided by the second polynomial, which will look like this. Okay, I could have also written it as this part here, or what we call the dividend over the divisor. So I could have had all of that on top over that. Now, that's important because, go away, don't send, because it matches what we've got here. So you'll see that at the end, we're going to end up with the quotient plus the remainder is still going to be over the divisor. If your remainder is 0, then it just means that you don't have this part on the end, but it does mean that you get like a little bit of extra with the quotient. You'll look at examples like that in year 11. So if this is what I've got, the first thing I have to do is set it up ready for long division of a polynomial. Now this part here is going to go out the front of our division calculation, just like that. And this is going underneath here. Now, setting out is really crucial for this. If it starts to get messy, you'll lose the whole thing. Now, you should have 4 different coloured pens as well. so that you can follow along changing colours each time. Okay, so our first step that we're going to do, change my colour, maybe I'll use blue. I'm going to get this one and I'm going to divide it by this one. Now my purpose for that is I need to work out this times that is going to give me this. So x cubed divided by x equals x squared. So the first term that's going up here is going to be x squared. Now you'll notice that I've lined it up on top of where the x squared terms go. Okay, so the next thing that we need to do is now I know that if that was multiplying this, what would I have to take away from this expression? So it's going to become this x squared multiply by x plus 2, which is going to equal x squared times x is going to be x cubed, x squared times 2 is going to be plus 2x squared. So now this is what I'm going to need to take away from this expression to see what's left. So minus, minus, make it really clear. X cubed plus 2x squared. Now every year when we do this, people think that I'm being pedantic and they don't need to keep doing all the same working as me, but you cut corners, you get it wrong, you got to do it again. Hurts more. Okay, so x cubed minus x cubed is 0. Now you know that that should be correct because this part here should always become 0 each time. Now 3x squared minus 2x squared will leave me with x squared. Now in order to do this again, to work out what the next part of this will be, I'm going to take this term down and this term down and add it back in. Okay, and now we repeat the process again. So again, the leading term of the polynomial that's remaining divided by the leading term of this polynomial. So that's going to be x squared over x is equal to x. Then I'm going to work out what would have to be taken away from this expression if that was true. So x multiplied by x plus 2 is going to be equal to x squared plus 2x. So we're going to have to take away x squared plus 2x from both of those expressions. Okay, so when I do that, x squared minus x squared is 0. X minus 2x will be negative x, and then I take this one down. Now again, I can see that this is correct because that leading term cancels out to be 0. Okay, so now repeat the process again. This is the term that we're looking at. So negative x minus x is equal to negative 1. So now work out what would have to be taken away. Negative 1 times x plus 2 is equal to negative x minus 2. Minus negative x minus 2. Negative x minus negative x cancels out to be 0. 9 minus negative 2 works out to be positive 11. So I've forgotten to put these terms back up here. So if you do miss it, it's always the answer for this part here. So x squared plus x minus 1, and then we've got remainder 11. So this is our quotient. This is our remainder. And we're actually finished this question now. We just normally would write remainder 11 at the top here. So if it asks you to state what they are, you would state quotient equals, and then you would state this up here, x squared plus x minus 1, remainder equals 11. If they asked you to put it into this form here, then my statement would look quite slightly different because it would be x cubed plus 3x squared plus x plus 9 divided by x plus 2 is equal to x squared plus x minus 1 plus 11 over x plus 2. And then that would be the end of it if it was asking me to state it into that form.